Hello everyone. I've never actually heard the title Solutions Architect in Europe. Maybe it doesn't exist. I'm a furious whiteboard scribbler, drinker of huge amounts of coffee, and occasionally throw grenades at my colleagues. I run a service called I'm part of a team that runs a service in Australia called CloudStore, which is, for one, an own cloud-based system, along with the File Sender project for researcher-focused storage. It runs almost entirely containerized. As of the end of next week, it will be 100% containerized. There is not a thing on it that will not be containerized. The thing that occurred to me, and I'm a bit of a fan of teaching my kids all sorts of weird physics things to the point where they make water out of subatomic particles using fridge magnets. Clouds are often like Schrodinger's cat paradox. A lot of the time the state is unknown, and in any successful cloud, with respect to the previous presentation, it shouldn't matter to the end user what the state of the cloud is because the experiment is still valid. In this case, the cloud is still valid because there is enough redundancy and contingency. A lot of this goes to the idea of, all too often, particularly in academia, a lot of people coming from high-performance computing and so on, drag this idea of servers are special. Services are irrelevant, servers are special. They're pets. In a very cloud-based approach, nothing is sacred. Everything is, they're not pets, there's no names, they're not special. My very first career position as a system administrator was actually at an abattoir, and believe me, when a cow was sick, it was put down. This extends to the cloud. Nothing is individually important. Everything is ephemeral. What we're doing here is nothing interesting, nothing new. It's just merely rehashing what the likes of Werner Vogels and so on will stand up on a stage at Amazon workshops and tell you. A lot of people ask then, aren't you complicating things? You're breaking things up. Surely a single server with a pile of monolithic services on top is simple. I can understand that. Funnily enough, it's actually harder to draw that at scale in, for example, the finite state machine diagrams than a cloud service is, and I'll show you that in just a little bit. A lot of people then turn around to me and say, well, why don't you use Ansible, Chef, Puppet, the usual suspects. They're not about services. If you look very, very carefully, these things are not about services. They're only ever about orchestrating a configuration and a beginning state of a machine. They are very rarely about actually keeping state as it should be. And the other thing I like about our containerization model is because things are so incredibly broken down, developers can focus on what it is they need to do. They stop hassling me, asking me, a RAID controller has just misbehaved, software RAID has failed, I've got packet loss on a network interface. Those are all non-developer problems. Let people who understand the hardware deal with that stuff, and the developers can actually just focus on the core thing. One of the paradigms that a lot of people are uncomfortable with when they start with containers is a container only ever runs one thing. You never start an SSH daemon inside a container. You never start multiple services. It's only ever one thing. Going a little bit further, maybe the origin of where CloudStore comes from. And I love talking about how big Australia is because we're an odd country that way. CloudStore itself stretches across the continent, which is approximately 47 milliseconds by the network. To give you a European analogy, that's Paris to Moscow. That, in our case, is a single compute cluster, and it even goes further than that. Part of the reason for that, of course, is that TCP, round-trip time, packet loss, these all add up to good put, along with the oddball choices that researchers make for tools. I mean, how many researchers out there are still trying to use Windows XP machines? A little bit further, this is how thinly we're spread. These tiny little blue dots, that's 50% of our population. And yet they all collaborate, and we're continually surprised at the collaborations we find. And they're continually saying, but I want to push more data between these groups of people. So CloudStore itself is now spread between 3 sites presently. We're looking at going to a few more and potentially a few dozen if I can get a particular technical concept working. But what this means is that we also have to handle network splits. No matter how many times somebody tells you 2 network links is enough, it's not enough. because the moment a backhoe operator runs a cable through, their tractor through one cable, there's a backhoe on the other side of the building, and this has actually happened, looking at a hole in the ground about to pull up the second cable that's running the opposite direction. So we try to handle this. We do our best to handle this within the paradigm and the scope of what we can do as an organization. But what it means, of course, is that we now have this ballooning of servers. I don't really want to take care of nearly 100 servers just to keep this redundancy going. That's actually a lot of work. You put 100 servers in a rack, can you guarantee that these things are all identical? My bet is you cannot. There are all sorts of ways of doing it, but then you end up spending more time trying to prove that they're identical rather than just treating your entire system as ephemeral throwaway and restart. And it's often occurred to me that by the time you sort of go with traditional methods, Ansible and so on, by the time you pile up all this software on a server, it starts looking like the, forgive me, I always get the name wrong, Sierpinski triangle. This continual fractal complexity that piles up. And then all of a sudden you end up with a situation where your server is now overheating, you're getting ECC memory errors, and you're context switching your kernel into hell. And you can't figure out why your system's not working. Because we've broken things down into the individual components as containers and all the rest of it, we can actually now break things down so that it is understandable. We can illustrate the path and the tree. Ultimately, everything we do is about service. I'm having to iterate this to my colleagues all the time. We don't care about servers. Don't monitor servers. Don't report SLAs on servers. That's totally uninteresting. What we care about is what the user sees. So the whole idea, of course, is to, by keeping things small, we reduce error. People can actually fit the conceptual model in their head. They can draw it on a notepad. They can scribble it on a whiteboard. They can understand it. State management is fast. Most of our containers, I should say, run read-only. Even if you were to exploit the container, there is no way for you to modify anything. You can't even get to a RAM disk. There is nothing there that people can modify and then exploit, unless they're very clever and can somehow execute out of a Redis key store. But most script kiddies cannot. It reduces the monolithic blocks. Once again, the failure mode, we lose, everybody knows that situation where they've had an infrastructure and they've lost one key machine and it's part of a monolithic block. And next thing you know, the entire service is down for 12 hours because you're trying to repair this thing. By treating your applications as ephemeral and mobile, immediately that problem goes away. And the only thing you really then need to worry about is your data that matters for that service. And so the industry buzzword is orchestration. I don't actually like that word. I think conducting is probably a little bit nicer, but we'll go with orchestration. Currently within RNet, we're using Rancher, which is a common tool to orchestrate our containers. We're looking at possibly moving to Kubernetes in the future, but unfortunately Kubernetes for some of our staff is a little bit too far down the road, a little bit too abstracted from what they're used to in their traditional backgrounds. So Rancher, on the other hand, gives us a nice web interface and an API interface we can use. Everything within CloudStore, well, will be as of next week, is 100% containerized. Our databases are containerized. Our metadata servers, we're using CERN's EOS as our storage technology. Every part of EOS itself is containerized in their own containers. Our web servers, app stacks, everything, nothing exists. To the point where I actively encourage programmers who want to jump onto a machine to do debugging to deploy a small shell system on that machine that when they exit, it immediately destroys itself and it's clean. So they can install those testing tools they want, they can access bits of data they want in the production environment and not ruin the production environment by mistake. Here's an example of, I mentioned before, being able to graph what it is. I have one of our junior programmers currently learning how to drive all this, and I've got him re-implementing the system by himself without using the existing code we've written. And he's currently linked it together, and this is actually the graph put together showing you the tree of dependency for a demo instance of CloudStore and how it's put together. That's actually not what the production instance looks like, but that's what he did 2 days ago. And as you can see there quite plainly, there is an order of sequence for which things must exist. And the scheduler will actually honor that sequence if it needs to start up an entire cluster from scratch. Another nice thing about this, of course, too, is that the containers being all individual, idempotent, and unique to themselves, you can choose the tool, the OS and the tool and all the rest of it that is preferred. Some of those developers, right there at the top, that's ExaBGP, the BGP tool written in Python. Just so happens that it's easiest to deploy on Ubuntu, so I'm going to put it on Ubuntu. So on down the stack, Alpine, Red Hat 7, we had CentOS in there, Fedora, and a couple others. But that's his work in progress and what he's done. The advantage there too, of course, is that things like Memcache end up being a 4 meg container that ship around the network. So to update Memcache anywhere is just a 4 meg transfer. That fits in a TCP window, no worries. Often people will argue about, people who don't like containers in the model will then stand there and argue about, but you can't update it. It's insecure, you've got bad software. This is all part of your lifecycle management, and this is where you need things like Jenkins. There's GoCD, Travis, you don't need to name any more CI environments. But the point is, they're updated continuously and in an automated fashion. So everything as a bonus of this, of course, is then tracked in Git. We've got branches, we can fork our Git repositories and build a whole new branch of our production infrastructure, experiment with it and merge it back. CI does it all. And of course, the standard CI rules, Git, schedule, all the rest of it, nothing special. But the important thing here is our orchestrator actually pins the versions. And I can break down the service into its versions and upgrade individual components as I go. Quite often, and I had this happen to me just the other day, a PHP update proceeded to obliterate the actual working state of the application stack for the thing in question. I could not figure out why. Identical RPMs, same source, same vendor, everything would not work. It took me, using traditional methods and a little bit of shell scripting, took me a good hour to clean that mess up for the first machine. And then, another couple minutes per machine after that in a test environment. In the case of Rancher or Kubernetes or others, because I've used the upgrade functionality, as you can see there, I've got a menu open that's simply illustrated. It's upgraded. It thinks it's successful. If I actually go look at the service stack, I will see 64 shut down containers, 64 running containers. And in this case, I can either choose to commit the upgrade, which it will clean up the old containers, or roll back. And it cleans its own state. But because you made everything idempotent and consistent, and you've already been running it anyway, you know the old state works. And this quote down the bottom is that same junior programmer. He broke something on his test instance, and he was so happy that he could roll it back in all of about 10 seconds. But one of the things here is that we can do lots of things. We took the previous presentation, finite state machines. We can handle that simply by orchestration. Choosing to halt, fail, all the rest of it, roll back. Event auditing, it's beautiful to feed the logs of our orchestrator straight into Elasticsearch, and you get a great chart of the behavior of your environment. And funnily enough, you know about network behaviors often before the network team does. And finally, as I noted, it's a get out of jail free card. You can roll back your environment very, very quickly. That said, it's not without its issues. A large part of it is you need to teach people the paradigm. The number of people I witness who will then go and install an SSH server in a container and try to access it, you just, no, stop, stop, stop. You don't need systemd inside a container. You're only running one process. It's your orchestrator that manages it. But the nice thing is that you get the audit trail as a bonus. There's no quick fix without doing it the proper way, but the quick fix also gives you the audit trail. And finally, the big thing is a lot of people will resist it. I found this. Sell on the value, as always. There's nothing magical there. Without the discipline, I've seen container environments appear like this image. This mishmash of just everything that looks cool. You still need to apply the same systems discipline. But that's about service-oriented thinking rather than how it is that you build the individual so on. But use your tools. There's a wealth of tools out there. This is not a new idea. There's a lot of people doing it. It's like I mentioned before, you turn up to an Amazon workshop. They're standing there saying containers, containers, containers. Microsoft is now starting to chant containers, containers. MS SQL, Exchange, now running containers. Another message is that everything is ephemeral. There is no such thing as a long-running container. It may be long-running simply by the fact that you've done no update, but in itself, it is not something that persists. It vanishes, it goes away. You still need your bootstrap, you still need your core infrastructure, but there are many ways of handling that, and it's not a big thing to manage 1 or 2 machines. Another message that I often carry forward is Docker Compose is a great prototyping tool. Don't use it for orchestration. That's not what it's for. Ignore anything Docker Incorporated says about orchestration. That's a personal opinion, but it's not uncommon. Don't use it for orchestration. Use it for your prototyping. A good tool will then convert it into Kubernetes or Rancher Compose format for you. I have seen this one mentioned, and I have seen it argued. There was a series of articles that went by a few months ago where somebody was all huffing and puffing and having a bit of a smirk at somebody who put their database in a container, saying containers suck. If you care about your data, you still need to manage your data in a sensible way. If you were to put your data in a VM and then destroy your VM and treat your VM as ephemeral, it would be exactly equivalent. Remove a disk from the server, it's equivalent. You still have to do your data management. Of course, losing your metadata is a great way to lose your job. But the other advantage too is that being ephemeral is that one of the jokes inside RNet is that people get frustrated that I'm a squirrel. I go chasing after the latest shiny tool. In reality, I'm about 12 to 18 months behind the industry, but the advantage of being ephemeral and being so mobile and being so componentized is that we can chase the technology as it improves and as it proves its worth. I can switch, as of next week, as I mentioned, once I have moved fully to a fully containerized environment, I can actually throw out my Red Hat 7 service and actually have a 10 meg Pixie boot that runs containers that then serves 100 odd servers for our existing cloud infrastructure. But because it's ephemeral, it is far easier to move and change what it is you're doing, adapt to what you're moving, even scale out onto other environments. Finally, our big thing going forward, we want to go to a VXLAN mesh. It's quite obvious, it's simple, but one of the things that's quite commonly done is people will set up containers on a host and do a port forward, as the documentation says, then suddenly discover that their firewall policy has been violated because it's now running through the Linux forwarding chain rather than the input chain. VXLAN fixes that. And it also allows us to be completely mobile with single points of failure or individual components that aren't multi-master. Rancher OS is one option we're looking at for minimal OS. Nothing special, but it's a 10 meg install that will boot in a network very, very quickly. The complete CI and CD integration to move to the finite state machine to track those failures. I want to see an update. I want the CI to do a unit test, run through Smashbox in the case of OwnCloud, and then confirm that it's okay and deploy it to production while I'm asleep. And the other thing, because our containers are so simple, there's no magic in there, there's no secret source, there's no passwords or anything like that. I can release the code onto GitHub and share it with people who want to do similar things. Thank you.
Thank you. Okay, thank you, David. Very nice presentation. So, time for questions. There's one at the back, please.
How do you handle storage persistency with your containers?
I do my best to make sure that there is individual components don't need persistent storage. In the case that there does need to be persistent storage, I look very carefully at what it is, and I've found that for the most part, the only thing that really needs to ever be persistent are stateful things, such as an SSH key on a host, just one example, decryption keys for encrypted at rest disks, that sort of thing. And they can be solved via other methods, such as console, etcd, those sort of tools. And to date, other than the databases, and the way I've handled that is our database, the scheduler will only start databases on servers that are marked as database server machines. And they, by implication, already have persistent data on local disk. But that said, if I were to be so foolish as to modify that policy to then fire up a few hundred database servers, they would all just get a clone of the production database. And then I'd have to probably clean it up down the road. But I can do that via a scheduled cron job anyway, or scheduled cloud, container cron job anyway.
Okay, there was this one question here.
What happens if rollback is broken?
So let me tell you a story about the number 42. I have a private network on the RNet network that I use for CloudStor and itself. And when I was asked what IP range I wanted to use, I chose 10.42/16. Everybody loves 42. Everybody loves Douglas Adams. I did an upgrade to Rancher, the orchestrator. And lo and behold, they declared they too loved 42. And they announced a more specific route for 10.42, which proceeded to bring down my entire infrastructure. This is when rollback did not work. I have no immediate answer. It's a hard one. It's one of these things where you do have to fall to human intervention. And unfortunately, I didn't catch this error despite testing in pre-production and all the rest of it, because it was a very, very subtle one. Mentally, as a human, I was so used to seeing 10.42 in any IP address anywhere that when I saw it appear in the test infrastructure, which is not supposed to have 10.42, my brain didn't see it. But that said, being completely ephemeral, the quick way for me to recover this entire thing was to simply go around, shoot every single node in the head using something like Ansible or GSH or that sort of tool, bring the entire infrastructure down. And I realize you probably couldn't do this at Dropbox, but, and then simply clean up that bit of state that created this network, then restart the infrastructure. And it actually, the longest part of this infrastructure was me, solving this problem to reboot this entire infrastructure was identifying the problem to start with as to why it occurred. Does that answer your question? Yeah.
Maybe then we can have over lunchtime to have a follow-up. How do you handle failed rollbacks? Okay. Any other question? Okay, so let's thank the speaker again.